All right, so for today, we're doing section 2.2 part B, analyzing graphs of polynomial functions. In other words, the extremas of these graphs. Okay, so we're analyzing extrema. That means high and low points. Okay, high and low points. So what are extrema? So for us, I mean, extremas come in different classifications. Okay, there can be absolute extrema, relative extrema, conditional as well. Um, we're only going to deal with the relative. Okay, relative extrema means like you can have more than one. Okay, so just to kind of draw like a little simple picture here, something like this. Okay, something like this has two relative maximums and one relative minimum. Okay, that means that it has one low point down here. Okay, and then two high points. Now you might say, yeah, but one of them is higher than the other. Well, then we would say that the other one is called an absolute extrema, but we're not talking about that today. Okay, they can both be relative extremas. So in other words, this point is the highest point relative to my interval. So if I only use like this part as my interval, like right here, from, let me highlight it, from here to here, if I only use that highlighted part right there, I could say that is my high point in that highlighted portion. If I only use this highlighted portion right here, I can say that that is my high point in that pink highlighted portion, right? Relative to what I decide to look at, those are my maximums or my minimums. So that's why they're called relative maxes, relative mins, because I can choose between what interval I'm looking at. Okay, so this graph would have two relative maximums, one relative minimum. Okay, we're going to do that today. On Friday, you guys were asked to graph functions using a table. And then using that table, after you graphed it, you were asked to find solutions. So you look to see where it crossed the x-axis, right? Today, we're going to do the exact same thing, but we're not going to be solving. We're going to be finding our relative extrema, our maximums and our minimums, okay? So let me move up here. We're going to do two examples, okay? Just like we did last time, just two examples. If you remember Friday's work, it was, again, I know I said this Friday, I'm going to repeat it today. It's not that the work was hard to do, it's that the work took a long time to do because you had to calculate 5 different values, and that takes time. It's not that it's hard, just put it into a calculator and let it help you do the calculations, right? It's not that it's difficult, it's just time consuming. But like I said, there's a lot of people that equate difficulty with the fact that it took a long time to do. Okay, and that's not really true. It doesn't have to be difficult. It might have just took some time. So go ahead and write this out. It says example number 1, use a table to graph each function. So we've done that already multiple times. Then estimate the x coordinate at which the relative maximum and relative minimum occur. So notice it doesn't say solve. Okay, after we graph it and I give you the answers, I'm going to go on Desmos and I'm going to check to see how close I am. Okay, I'm going to guarantee you that I'm probably going to be wrong on at least one of them. Okay, but it's okay as long as I'm close. Okay, I got to get close to the right answer. I can't be really off. So we're going to use a table to graph each function. Then we're going to estimate the x coordinates. In other words, just the x coordinate, not the y, just the x value, where the max and the mins occur. Okay, so let me go ahead and make a coordinate plane here. Hold on, I don't want to do it with a highlighter. So here's my coordinate plane. Again, on your homework, you already have it there, so you don't have to worry about having to draw it. So we're doing a 5 by 5. So 5 to the left, 5 to the right, 5 up, 5 down. I'll label these. I just like to label the positive axes because or else it gets kind of hard to put like -1, -2, -3 in small print. So there you go. Remember, this is going to take a little bit of time, but it's not going to be difficult to do. So don't feel like, oh my gosh, these problems are hard. Like, no, we're just punching numbers in. So here we go. They said use a table to graph. So here we go. I'm going to use a table. And I'm going to plug in -2, -1, 0, 1, and 2. I'm going to try to do the calculations as fast as I can, okay? But I'm still going to have to kind of like go through them, make sure that I'm doing them right, okay? But I'm going to plug in a -2, a -1, a 0, 1, and a 2, and let's see what we get. So here we go. So f of -2. This is the part that takes a long time, okay? F of -2, I'm going to plug it into my equation. 2 times -2 to the third minus 3 times -2 plus 1. That's 2 times -8 plus 6 plus 1. That's -16 plus 6 plus 1. Well, that's -9. So -9. I'm going to go to my graph and notice my graph doesn't fit a -9. At -2, I can only go all the way down to -5, maybe -6. But you know what? I'll just go an extra 3, 1, 2, 3. I'll put one right here. It's okay. If it doesn't fit perfectly, I'm okay going a little bit further. So there we go. This is -2, -9. Okay, and you don't actually have to put that one there, but it's good to kind of put at least 5 points. So here we go. -1 is my next one. So f of -1 is 2 times -1 to the third minus 3 times -1 plus 1. Again, I'm just plugging it into an equation. I'm not doing anything special. So that's 2 times -1 plus 3 plus 1. That's -2 plus 3 plus 1. Well, that's 2. So at -1, it's 2. So here's my point. At -1, it's 2. Plugging in 0 is pretty easy because it just kind of wipes everything out. So f of 0 is 2 times 0 to the third minus 3 times 0 plus 1. Well, that's just equal to 1. So at 0, it's 1. And now we got 2 more to go. Then we can draw the picture. Then we can write down our x values for the extrema. So f of 1, that's 2 times 1 to the third minus 3 times 1 plus 1. Okay? So that's 2 times 1 minus 3 plus 1. That's 2 minus 3 plus 1. 2 minus 3 is -1 plus 1 is 0. So at 1, it's 0. And then one more, f of 2. So 2 times 2 to the third minus 3 times 2 plus 1. 2 times 8 minus 6 plus 1. 2 times 8 is 16. Minus 6 plus 1 is 11. That's definitely out of range. So all I'm going to do is I'm going to go to 2 and I'm going to put the point like kind of high, like way up here. I know that's not 11, but that's okay. Now I'm going to draw this thing from left to right. So I'm going to start down here. And there you go. I drew it as best I could. Okay. Is this the correct answer? I don't know. We'll find out right now. We'll look at Desmos. But now I'm going to zoom in on this because the answer to the question is, what are the x values where the high point and the low point occur? So let me zoom in. So I would say that maybe my high point is right about here. That's not exactly -1. That's like -0.9. Would you guys agree? Pretty close to -0.9. This point right here. Right? Here's the high point. About -0.9, -0.8, something like that. Okay? And then for the other point, the low point, I think that's somewhere about right there. Maybe that's about a 0.9 as well. So maybe -0.9 and 0.9. Those are my two x values. So let me write that down. And then I'm done with this problem. So I'm going to say the relative maximum. So the high point is at x equal to negative 0.9. And the low point, the relative minimum, is at x equal to 0.9. And that's my solution. Okay? So let me go on Desmos and let me show you what the actual answers are, and let's see if we're actually right. But what I've done right here, okay, what I finished doing right here is completely acceptable. Okay? I calculated the points. I put the points on the graph. I drew the best graph I possibly could. And then I told you where the high points and the low points are located based on the x-axis. Okay? So the high point at negative 0.9, the low point at about 0.9. Okay? And I'm good. Now to see the actual answer, we'll go to Desmos really quick. Go here. Desmos. Here's the actual solution. So look, the high point is actually at negative 0.7. See the x value? Negative 0.7. The low point is at 0.7. Did I get it right? No, I didn't. But they didn't say to find the exact solution. They said find the approximate, like find an estimate. Okay? So am I okay with that? I'm only 0.2 off, 2/10. That's not bad. Okay? That's not bad. So it's not that when you guys do this work, you got to get it perfectly right. Because if you get it perfectly right, there's a good chance it can happen. But to getting both of them perfectly right, that usually means that you've used a different, maybe you use this to find the answers, which is okay. But the purpose of this exercise is not so much that we have to get it right. We just got to get it close. Okay? We just got to get it close. So we're going to do one more. Okay? And that's going to be this next one that I have up there. And then we're done. So same instruction. So you don't have to worry about a new instruction. Same thing. We're just going to graph a different one. And the reason why I'm doing one that's negative is because on your homework, you have a positive one and you have a negative one as well. So I want to make sure I do one of each. Okay? None of these are your homework problems. Okay? So Jake, do me a favor. Jake, go over there. I'm trying, but I just can't. It's high school, not elementary. So I kind of have to behave a little bit. So with this one right here, we are going to do the same exact thing. We're going to graph, and we are going to make a table, and then we're going to evaluate. And after we evaluate, we're going to guess where our high and low points are. And at that point, we will label the max and the mins. Okay? So here we go. Let me make a real quick chart. I don't think I made this one square, but that's okay. There's 1, 2, 3, 4. I think I made this a 4 by 5. Not a big deal. 1, 2, 3, 4. 1, 2, 3, 4, 5. And then I'm going to make my table here. X, Y. And using the same numbers, -2, -1, 0, 1, and 2. So let's find out the values. I'm just going to plug them in. I'm going to do them a little quickly, a little faster than before. Okay, just so that we're not taking as long to do this one. I'm sure you kind of get the idea. So here we go. -2 times -2 to the third minus -2 squared plus 4 times -2 plus 1. Well, this is -2 times -8 minus a 4 minus an 8 plus a 1. That's 16 minus 4 minus 8 plus 1. So 16 minus 4 is 12, minus 8 is 4, plus 1 is 5. So here we go, negative 2, 5, up here. Okay, plugging in negative 1. F of negative 1 is negative 2 times negative 1 cubed minus negative 1 squared plus 4 times negative 1 plus 1. Again, you don't have to show all that work when you guys are writing your notes. Just put the answer, like f of negative 2 is 5. F of negative 1 is, we'll figure it out right now. So this is negative 2 times negative 1 minus 1 minus 4 plus 1. So that's 2 minus 1 minus 4 plus 1. That's negative 2. So at negative 1, negative 2. Okay, now 0. At 0, it's just going to equal to 1. So I'm just going to write that down here. F of 0 is just 1. Because all the x's are going to cancel out. When you plug it in, 2 times 0 to the third is 0. 0 squared is 0. 4 times 0 is 0, right? So we just got a plus 1 there. So f of 0 is 1. So I'm going to put a point right there. Now let's plug in f of 1. So I'm going to kind of move this over here. F of 1 is negative 2 times 1 to the third minus 1 squared plus 4 times 1 plus 1. So this is going to be negative 2 minus 1 plus 4 plus 1. So that's equal to 2. So it's 1 comma 2. And now the last one, f of 2. So that's negative 2 times 2 to the third minus 2 squared plus 4 times 2 plus 1. That's negative 2 times 8 minus 4 plus 8 plus 1. Negative 16 minus 4 plus 8 plus 1. That's 12. Oh, no, wait. That should be negative 16. Minus 4 is negative 20 plus 8 is negative 12 plus 1 is negative 11. So negative 11. That's out of my grid, but I can kind of put it way down here. That's fine. Okay? So here's my graph. Something like this. I mean, just graph it as best you can. It doesn't matter if you're perfect, but you got to make sure you touch all those red points, right? And you're kind of going through them nicely. Okay? Don't do like sharp lines. Like there has to be a turn to it. So now let me go to I'm going to zoom in, and it looks like my low point is right here, right there. That would be negative 1. And my high point looks like it's right about there. What do you think? Like a 0.8? So a 0.8 and a negative 1. So let me write that down. And then we'll check Desmos to see if I'm close. So, all right, my relative maximum is at x equal to 0.8. And my relative minimum is at x equal to negative 1. So we'll see right now if I'm close. So again, my high point happens when x is 0.8. My low point when x is negative 1. Let's check this out. All right, let's see. So according to this, my low point happened at negative 1. So I got that one, right? And that's just based on how you drew your picture, right? You drew your picture a little crooked. Maybe it's not negative 1, but it's okay as long as it's close. If you got negative 0.8, if you got negative 1.2, that's fine, okay? The high point, I got 0.6666, basically 0.7 if you round it. I said 0.8. I'm off by a bit, by 0.13, but that's okay. It's not bad, okay? Does my graph look about the same? Well, this goes as low as negative 2, as high as 2.6. Let me see what mine looks like. So mine does go as low as negative 2. You can see it right here. But it does not reach 2.6. This is about 2.6 right there. It's not as high. So my graph isn't perfect, but it's close. It's good enough. Okay. Graphing is probably the worst way to solve things, but it is one of the things that we learn to do because usually we know how to solve using like elimination, substitution, using formulas. But when those don't work, because there are times when all that stuff doesn't work, you do have to kind of fall back to graphing. So it's good to know how to graph things to at least get some basic solutions. So for your homework today, guys, you got two problems in the back of your paper, okay? Numbers, I think 12 and 13. I think, let me see. No, I'm sorry, 5 and 6. I was in the wrong section. You guys have numbers 5 and 6. None of these are the ones on your homework, but they are very similar to the ones on your homework, okay? Use the tables that I use the same numbers. Take your time. If you need calculators, I got some up here. Go ahead and borrow some. I can bring out more if you need them. But just take your time. Try to do one before the bell rings. So we got 24 minutes. Try to at least get one out of the way. Maybe you can do both, okay? But try to get one out of the way, all right? So if you guys, I'll give you guys time to work on that. Feel free to move around if you'd like.